And we basically use two types of reasoning. One type is called deductive reasoning, and the other kind is called inductive. Now, deductive reasoning is based on fact. Now, when I say fact, I don't mean that something is a fact, but that it's a scientific fact. I mean, it could be a fact that I wear flip-flops every Wednesday, but that doesn't make it a scientific fact. That doesn't make it deductive reasoning. We also consider law. Once again, this is scientific law as opposed to scientific theory. Okay? Inductive reasoning is based on an observation. An observation specifically of a pattern and inductive reasoning, you come up with a conjecture. Now, a conjecture is basically like an educated guess. Okay? We can't prove inductive reasoning, but we can come up with a conjecture that says that this is likely to happen. When we use deductive reasoning, we're using facts, laws, to prove something is true or false.
Deductive reasoning is one of the most powerful techniques in order to actually establish the validity of conjectures. So let's take a look at this sort of collection of ideas together. First, let me begin with a little myth here. So there's a myth that tapping the side of a carbonated beverage will prevent it from foaming over. So you might have heard this thing that you have some sort of carbonated beverage, and so you want to sort of just tap it a little bit, and somehow that's going to prevent it from foaming over. And my question to you is, do you really believe that? Do you think that is true or not? Just a little tap is going to prevent that. Well, I shook a can, and it's tapped it a little bit, and then I opened it up, and you know what happened? You won't believe it. You want me to show you right now? Actually, no, I'm not going to show you. But instead, what I'm going to do is tell you that when I tried it, in fact, it foamed all over. So I decided that myth is actually false using inductive reasoning. I experimented and saw what happened, and so inductive reasoning tells me the statement was false. Let's take another example. So there's a myth about swimming, and maybe you've heard this too. There's a myth that if a person goes swimming less than 1 hour after eating, they will likely get a cramp and drown. Doesn't that sound scary? However, scientists have actually shown that eating before swimming is not a cause of death, and therefore the myth is false, but this time the myth is false using deductive reasoning, because we used scientific reasoning to actually show that, in fact, we can use logical steps to get there. So there's an example of deductive reasoning. Now we're going to use inductive reasoning to make conjectures. Now conjectures, which in some sense are sort of very educated guesses as to what we think might be the situation, are probably one of the greatest parts of mathematics. Certainly creating conjectures involve some of the most creative aspects of mathematics, and probably my favorite part of math. Because to generate new mathematics, we first have to make conjectures. Make educated guesses. Let's take a look at some examples. Let's just start off fairly simply. I'm going to give you a list, and let's see if we can conjecture as to what we think the next element in the list is. Well, here we see A, E, I. Well, I'm going to actually guess O, because I'm going to think this might actually be the vowels, A, E, I, O, U. So I'm going to conjecture that the next entry would be O. How about this list of numbers? Let's take a look. I see 7, 14, 21, 28. Well, these look like the multiples of 7 written in order. So I'm going to conjecture that the next entry is 35. Notice, by the way, that that's not a proof. We don't know what the next entry is. I'd somehow have to prove that using some other information that someone tells me. But I can certainly make a conjecture. And my conjecture is, given the evidence, I think the next term will be 35. How about a little geometric one? Here's one. And here's how I'm going to interpret this. I'm going to see I have all these circles here. And I see that in each circle what I do is first I have one piece, then I put a line down which divides it into two pieces. Then we divide that into 4 equal pieces. And so maybe the next term, I might conjecture, would be what we get when we double again. Notice that first I had 1, then I doubled, and I have 2, then I doubled, and I have 4 equal pieces. So I might guess the next term would be doubling again and have 8 equal pieces. This is a great example, by the way, where there might be more than one reasonable conjecture. And without knowing more information about the situation, we might just be able to sort of have to shrug our shoulders and say, I don't know which one's right, but they're all reasonable conjectures if you can give a little rationale for why you think your educated guess, your conjecture, is a good one. Enjoy making conjectures. It's one of the greatest things you can do in math. Sometimes we can make a conjecture about some kind of mathematical statement. For example, let's take a look at this one. The product of 2 odd numbers is a blank. Well, how might we go about making a conjecture? Well, we might take a look at just making a whole bunch of examples and seeing if we can build some insight. That's one of the greatest ways to build insight in mathematics and even in other areas, is to look at examples and see what's going on. This is a question which says, let's take a look at the product of 2 odd numbers. So how about we start off with 1 and multiply it by another odd number, let's say 3. I see the answer is 3. How about we take another odd number, let's say 5, and multiply it by some odd number, let's say 7, I see 35. How about another odd number? Let's take, let's take 11 and multiply it by some odd number, let's say 9. I see 99. Now, what can I conclude about these numbers? When I look at 3, 35, and 99, I notice one thing. None of them are even. So, in fact, they all seem to be odd. So my conjecture is the product of 2 odd numbers is an odd number. Let me just caution you to notice that that doesn't prove it, but it's a great conjecture looking at this data. Let's take a look at another example. This is a more visual one. The number of circle parts formed by n diameters. Now let's think about that. That's sort of a crazy question. In fact, the first thing I would do seriously is scratch my head and say, So I would immediately draw a picture. It's about something that's visual, so I'm just going to draw a picture, and I honestly don't know what I'm going to do after that. There's a circle, there's the center, and I have to draw a bunch of diameters in. N represents some unknown number of diameters. So let's suppose that I put in 1 diameter. If I put in 1 diameter, how many circle parts do I have? I see 2. If I draw another diameter, how many circle parts do I have? I see 1, 2, 3, 4. If I draw another diameter, how many circle parts do I have? 1, 2, 3, 4, 5, 6. Let's just do one more. So now I have 1, 2, 3, 4. I've got 4 diameters. And how many circle parts? 1, 2, 3, 4, 5, 6, 7, 8. So when I drew in 1 diameter, I had 2 circle parts. When I put in 2 diameters, I saw 4 circle parts. When I put in 3 diameters, I saw 6. I'm seeing a pattern. It seems like the number of circle parts is double the number of diameters. So my conjecture here would be that the number of circle parts formed by n diameters is equal to 2n. That's my conjecture. Now we still have to prove it if we want to actually call it a true mathematical statement, also known as a theorem. So Beth is an avid bird lover, and she noticed that around her neighborhood there were the same number of mockingbirds, cardinals, and blue jays. And outside her kitchen window, she put a little bird feeder up and put a certain type of food in there. And then she started to count over the days what birds were brought into the feeder and were feeding from the feeder. And here is the data that Beth collected. You can see day 1, day 2, day 3, day 4, day 5, and the various birds and the number. So for example, there were 5 mockingbirds on day 1, 7 cardinals on day 1 and 1 blue jay on day 1 that ate from her feeder. And the question that she wonders is, what can she conjecture about the bird's taste in terms of the food left out? So she's leaving out this food in her feeder. Which birds like it? Well, looking at the data, she could conjecture possibly that since there are so many cardinals that seem to be drawn and attracted to the food that she's leaving out, that in fact it's the cardinals that seem to be most desiring of her food that she leaves out of her kitchen window. So I would say that the bird feed that she's leaving out is most desired by the cardinals. That would be a reasonable conjecture given the data that she made during her observations.